Now let us discuss question number 6. For part A, we have to sketch the graph of y equals a to the power x plus 4 using transformation of graph. Now for B part, we have to use the trapezium rule for calculating the integral of integral 2 to 3.5 to the power x minus 2x dx. Then for part C, we can use the result of part B to find the two integrals. This is the graph of y equal to a raised to x, a greater than 0. The graph crosses the y-axis at 0, 1 and x-axis as asymptote. Therefore, equation of asymptotes are y equals 0. Now the graph of y equal to ax to the power x plus 4 is obtained by translating the graph of y equal to a to the power x by a unit 4 in the positive direction of y-axis. Therefore, the graph crosses the y-axis at 0, 5. Now the equation of asymptote is y equals 4 The 6 values of y are given. Therefore, take n plus 1 as 6, which implies n equals 5. Now, h equals b minus a by n, that is 3.5 minus 2 by 5, that equals 0.3. Now, integral 2 to 3.5, 2 to the power x minus 2x dx equals 0.3 by 2 times 0 plus 2 times 0.3246 plus 0.8629 plus 1.6643 plus 2.7896 plus 4.3137 Now this equals 0.15 times 2 times 5.6414 plus 4.3137, that equals 0.15 times 15.5965 that equals 2.339, approximately equal to 2.34. Here we have to find the value of integral 2 to 3.5 2 to the power x plus 2x dx using the result of part B, that equals integral 2 to 3.5 2 to the power x minus 2x plus 4x dx, that equals integral 2 to 3.5 2 to the power x minus 2x dx plus integral 2 to 3.5 4x dx. Now using b part, we got the answer of first integral as 2.34 plus integral of 4x is 2x square to the limit 2 to 3.5. It's 2.34 plus 16.5 equals 18.84. Now for second part, we can rewrite the integral 2 to 3.5 to the power x plus 1 minus 4x dx as integral 2 to 3.5 2 times 2 to the power x minus 2x dx, that equals 2 times integral 2 to 3.5 2 to the power x minus 2x dx, that equals 2 times, using the result of part B, 2.314, that equals 4.68. The equation of circle C1 is given as x square plus y square plus 8x minus 10y equals 29. And we have to find the coordinates of center C1 and the exact value of radius. For this, first of all, try to convert the equation into standard form. Now rearrange the equation as x square plus 8x plus y square minus 10y equals 29. Now convert the x square plus 8x into square form by using completing square method. That is x plus 4 the whole square minus 4 square plus y minus 5 the whole square minus 5 square equals 29. That equals x plus 4 whole to the power 2 plus y minus 5 whole to the power 2 equals 70. Or the standard form as x plus 4 the whole square plus y minus 5 whole to the power 2 equals root 70 whole square. Now comparing with the standard form, we got center as minus 4, 5, radius as root 70. Now for part B, another circle C2 is given as x minus 5 whole to the power 2 plus y plus 8 whole to the power equals 52. And we have to prove that the two circles C1 and C2 neither touch nor intersect. Here for circle C1, center equals minus 4, 5, radius R1 equals root 70. For circle C2, center equals 5 minus 8, radius R2 equals root 52. Sum of the radii R1 plus R2 equals root 70 plus root 52. That equals 15.58. Now calculate the distance between two centers. Using distance formula, root of x2 minus x1 the whole square plus y2 minus y1 the whole square. root of 5 plus 4 whole to the power 2 plus minus 8 minus 5 whole to the power 2, that equals root of 9 square plus 13 square, that equals root 50 equals 15.81. A sum of radii less than distance between two centers. Hence the two circles C1 and C2 neither touch nor intersect. For the first part, we need to solve the trigonometric equation 5 sin x tan x plus 13 equals cos x. Now for solving, rewrite tan x as sin x by cos x. Therefore, the whole equation becomes 5 sin square x by cos x plus 13 equals cos x. Now 5 sin square x plus 13 cos x by cos x equals cos x. Now cross multiplying, 5 sin square x plus 13 cos x equal to cos square x. Now rewrite sin square x as 1 minus cos square x. 5 times 1 minus cos square x plus 13 cos x equals cos square x. Now expanding, 5 minus 5 cos square x plus 13 cos x equals cos square x, that equals 6 cos square x minus 13 cos x minus 5 equals 0. This is a quadratic equation in cos x. We can use either the quadratic formula or the factorization method for solving this one. Now 6 cos square x minus 15 cos x plus 2 cos x minus 5 equals 0. 3 cos x times 2 cos x minus 5 plus 1 times 2 cos x minus 5 equals 0 equals 2 cos x minus 5 times 3 cos x plus 1 equals 0. 2 cos x minus 5 equals 0 implies cos x equal to 5 by 2 equal to 2.5, which is not possible. The value of cos x lies between minus 1 and plus 1. Now 3 cos x plus 1 equals 0 implies cos x equals minus 1 by 3. That is x as cos inverse of minus 1 by 3 equals 1.909 radian. The temperature inside a greenhouse is modeled by the equation H equals 10 plus tall sine of KT plus 18. The K is a constant. And it is given that the temperature inside the greenhouse was 20 degrees Celsius at 6 am. And we have to find all possible values of K. Now it is given that at 6 am, the temperature inside the greenhouse is 20 degrees Celsius. It's 20 equals 10 plus 12 sine of 6K plus 18. Now sine of 6K plus 18 equals 10 by 12. That equals 5 by 6. Then 6k plus 18 equals sine inverse 5 by 6. Now one value of 6k plus 18 equals 56.4 degree. Next value is 180 minus 56.4 degree, that equals 123.6. Hence after simplifying, we got one value of k as 6.41 and another value as 17.59. Now attempt to calculate the maximum temperature inside the greenhouse. For maximum value, we have sine of kt plus 18 as 1. Therefore, H equals 10 plus 12, that is 22 degrees Celsius as the maximum temperature. Now for part C, we need to find the time of a day at which the maximum temperature occurs. That is, for maximum temperature, sine of kt plus 18 equals 1. That means kt plus 18 as 90. Now we can take any of the two values of k here. 6.41 times t plus 18 equals 90. Then t equals 11.23. That is time of the day as 11:14. This figure shows the sketch of a curve C with equation y equals 2x to the power 3 by 2 times 4 minus x. And P is a stationary point of C. And we have to calculate the x coordinate of P. Now since the stationary points are given by dy by dx equals 0, first of all let us try to find out dy by dx. Then for that, try to arrange the function y equals 8x to the power 3 by 2 minus 2 x to the power 3 by 2 times x is x to the power 3 by 2 plus 1, that is x to the power 5 by 2. Now dy by dx equals, we know that differentiation of x to the power n is n x to the power n minus 1. Therefore 8 times 3 by 2 x to the power 3 by 2 minus 1 is 1 by 2 minus 2 times 5 by 2 times x to the power 5 by 2 minus 1 is 3 by 2. That equals 12 x to the power 1 by 2 minus 5x to the power 3 by 2. Now the stationary points are given by taking dy by dx equals 0, which implies 5x to the power 3 by 2 equals 12x to the power 1 by 2. That implies x to the power 3 by 2 by x to the power 1 by 2 equals 12 by 5, which implies x as 12 by 5. Now for part B, it is given that region R1 is bounded by C and the x-axis. The region R2 is bounded by C, the x-axis and the line with equation x equal k where k is a constant and we need to find the value of k. Now let us try to find out the integral of given function. Let's integral 8x to the power 3 by 2 minus 2x to the power 5 by 2 dx. Now we know that integral of x to the power n is x to the power n plus 1 by n plus 1. Therefore 8 times x to the power 3 by 2 plus 1 by 3 by 2 plus 1 minus 2 times x to the power 5 by 2 plus 1 by 5 by 2 plus 1 that equals 8 times x to the power 3 by 2 is x to the power 5 by 2. Now 3 by 2 plus 1 is 5 by 2. Taking the reciprocal, we got 2 by 5 minus 2 times x to the power 5 by 2 plus 1 is x to the power 7 by 2 by 5 by 2 plus 1 is 7 by 2. Taking reciprocal, we got 2 by 7 that is 16 by 5 x to the power 5 by 2 minus 4 by 7 x to the power 7 by 2 plus c. Now this function satisfies x equals k. Therefore x equals k implies 16 by 5 k to the power 5 by 2 minus 4 by 7 k to the power 7 by 2 equals 0. Now solve for k. 4 by 7 k to the power 7 by 2 equals 16 by 5 k to the power 5 by 2. Then k to the power 7 by 2 by k to the power 5 by 2 equals 16 by 5 times 7 by 4. That equals 28 by 5. Now k to the power 7 by 2 by k to the power 5 by 2 is k to the power 7 by 2 minus 5 by 2. That is k of 28 by 5. This question relates to geometric series. Initially there were 2000 domains on the island, means you can take 2000 as a or first term. The number of domains will increase by 3%, means r equals 103%. Now we have to calculate the number of domains on the island after 6 years, means calculate 7th term or use 7. Now for this geometric series, check A as 2000, r equals 103%, equals 1.03. Now use 7 as ar to the power n minus 1, that is ar to the power 7 minus 1, that is equal to 6. 2000 times 1.03 whole to the power 6, that equals 2390 approximately. Now for part B, we need to find the equation relating the number of volts in the form n equals AB whole to the power t, given that 4 years after the number of volts are 3690 and 7 years after the number is 3470. Now after 4 years, they were 3690 volts means U5 equals 3690. Now after 7 years, they were 3470 volts means U8 as 3470. Now U5 equals 3690 means AB whole to the power 4 as 3690. B is the common ratio. U8 equals 3470 means AB to the power 7 as 3470. Now dividing 2 by 1. B cube as 3470 by 3690. Now taking cube roots, B equals 0.98. Then A as 3690 by 0.98 whole to the power 4, at approximately equal to 4000. Now we need to form the model as n equals AB whole to the power t, that equals 4000 times 0.98 whole to the power t. Now for part C, let's try to calculate the value of t when the number of domains on the island is equal to the number of volts. Now set 2000 times 1.03 whole to the power t equals 4000, 0.98 whole to the power t. Symbolize 1.03 by 0.98 whole to the power t equals 4000 by 2000, it equals 2. That is 1.051 whole to the power t equals 2. Taking logarithms on both sides, t log 1.051 equals log 2, then t as log 2 by log of 1.051, that equals 13.9.